Hi, I'm Martin Sweatman, and in this video I'm going to continue my review of the Younger Dryas impact debate research. Now, so far we've covered the published research from the original Firestone paper in 2007 up to the end of 2011. And so you can see the list of papers here. Now, this time we're going to cover 2012. Now, immediately we can get rid of these conference proceedings here, Quaternary International. We're only interested in full peer-reviewed journal papers. And we can get rid of this paper here by Rick et al. I've read through it and it doesn't seem to have anything to do with our subject, so I don't really know why it's in this list. So I'll get rid of that one. So that still leaves quite a lot to get through, so let's make a start. Remember where we got to last time? The Comet Research Group had found evidence in the form of things like magnetic grains and nanodiamonds and so on, which suggested a massive cosmic impact had triggered the Younger Dryas mini ice age nearly 13,000 years ago, resulting in massive death across the continent and beyond. But their opponents, who are leading advocates for alternative theories for the demise of human cultures and megafauna at this time, had chipped away at their evidence, calling the impact theory into question. However, as we've seen by the end of 2011, we've seen that independent research groups had begun to confirm their evidence, and specifically an abundance of iridium-rich magnetic grains at Murray Springs had been confirmed at the base of the Black Mat, and nanodiamonds had been confirmed at the Younger Dryas boundary in Belgium and in Greenland. But the nanodiamond evidence from sites in North America has been rebutted by Dalton et al., who thought that only graphitic nanocrystals had been observed, not nanodiamonds. Given the evidence from Belgium and Greenland, we can expect that work to be flawed somehow, but we don't know how just yet, so we can't be sure about that. We should also not forget the Requiem paper from 2011. So despite attempting to kill off the impact hypothesis, the paper was itself flawed and dead as a dodo as soon as it was published, essentially, mainly because of the nanodiamond evidence from Greenland that was published just before it. So to sum up, given the evidence that has now been confirmed by independent research groups in favor of the impact hypothesis, it would be a major surprise if it turned out to be wrong. And without convincing alternative explanations for the existence of nanodiamonds at the base of the Younger Dryas Black Mat in Greenland, Belgium, and perhaps North America, along with these iridium-rich magnetic grains at Murray Springs, the cosmic impact scenario is very much alive and kicking. Nanodiamonds have not been observed to form in natural wildfires, but they are known to exist in meteorites and to be formed by high-energy explosions. And they've been recovered from sediments near known impact craters. And iridium is a very rare metal in Earth's surface, so a cosmic impact is really the only viable explanation for these signals. So anyone from here on who's going to take on the impact hypothesis better have something really good. So what happened next? Actually, the next paper published is this one by Fayek et al. Let's have a look at it. Now, this is a really interesting and important paper in my view. That these researchers, they went back to Murray Springs and took a much closer look at the magnetic grains found at the base of the Black Mat, which we already know are enriched in iridium. And by using various types of powerful electron microscopy, they were able to see that the surfaces of many of these grains were patterned, and they call it a rhomboidal pattern, or having a raspberry-like surface. You can see these raspberry-like patterns here. Now, they conclude this is proof that these grains were generated by a massive explosion. This is what this textured surface tells them. It's evidence of very quick cooling or quenching of these grains from an extremely high temperature. So according to this argument, we can be absolutely sure that the explanation put forward by Vance, Haynes, and others, that these are just normal cosmic dust particles concentrated at the Black Mat, is wrong. We can put that idea to bed once and for all. And remember, these rhomboidal iridium-rich magnetic grains are found in the same place as nanodiamonds at the base of the Black Mat at Murray Springs, although the nanodiamond has been questioned by Dalton, of course. So this implies that the nanodiamonds, if they are really there, as we suspect, are also the products of a cosmic collision, not just as the Comet Research Group thought. So just a week after this paper by Fayek was published, another paper claimed to have found the Younger Dryas black mat, this time in Mexico, which, if true, would extend its range into a new continent. Okay, so here we have Israel Alcantara from Mexico, joined by the Comet Research Group. And they find a variety of impact markers like nanodiamonds and various types of spheral and so on. What they think is the Younger Dryas black mat in lake sediments from the bottom of a lake in Mexico. Now, this is very detailed work, and especially the nanodiamond evidence is very compelling. And they also tighten up the comet impact scenario. Essentially, they propose in this paper that Earth collided with a trail of comet debris. That's their new thinking on the mechanism. But there's a major problem with this work. It's completely hamstrung by the age depth model they find for the lake sediments. Unfortunately, they're unable to show that the sediment layer they're investigating at the bottom of this lake in Mexico corresponds to the Younger Dryas black matter. And here's why. So this is their age depth model for these sediments. And these red circles, which they've kind of joined by this line, these red circles are the radiocarbon data points that they previously had before embarking on this research. Now, this is where they think the Younger Dryas black mat is. Now, to fill in this gap between these two data points here, they take 6 new samples to radiocarbon date from around what they think is the Younger Dryas black mat. And unfortunately for them, these new data points are the ones in blue, and they're completely inconsistent with the red ones. Now, it's a massive problem for this work. I can just imagine their reaction when they got this new data back from the lab. It must have been devastating for them. It's pretty obvious something has gone wrong, but until that's cleared up, we just have to accept the data as it is. I mean, if this was just a single anomalous data point, we might have been able to ignore it, but 6 mutually consistent data points lying on a trend cannot simply be dismissed. The authors try to argue that other indicators like the pollen record in the sediment show that this is indeed the Younger Dryas black mat, but even if that's true, we just can't ignore this strange radiocarbon data. So unfortunately, it means we have to reject this work. Now, because we have to reject this paper, we don't need to address the responses or the counter responses to it. However, I will just briefly pause with the Comet Research Group's counter response to criticisms of this paper, some of which are justified, because it perhaps reveals why Dalton et al. Were unable to confirm the nanodiamond evidence at sites across North America. And apparently it's because they looked for the nanodiamonds inside charcoal particles only, whereas the Comet Research Group only ever found them inside what is known as glassy or amorphous carbon. So apparently they were looking in completely the wrong place. Now, I checked the Dalton paper from 2010 carefully again, and actually it's just not clear exactly where they obtained their samples from. It's not even clear if they're from the Younger Dryas boundary. Nevertheless, it's still the case that the Comet Research Group's nanodiamond evidence from North America has still yet to be confirmed. Okay, so passing swiftly on, the next work we come to is by Pigatti et al. Now, I find this to be a really interesting paper. These researchers show that, in fact, there are lots of black mats at different sites in North and South America. Here we can see some of them. So there's not just one black mat. There are many, all with different ages. And moreover, they find, let's see their data, they find some of the same signals of an impact at these different black mats. So they measure things like the concentration of iridium in the bulk sediment and in the magnetic spherules, and the number of magnetic spherules, and so on, just like the Comet Research Group. And although their data is pretty sparse, I think they've done enough to show that the Younger Dryas black mat is not alone. There are several black mats with similar impact markers from the last 40,000 years, because the ages of these mats, these black mats that they find, as you can see from here, the ages are given here, they vary from, say, 40,000 years or more to much more recent ones like nearly 6,000 years ago. But then these authors, these researchers, make a fatal logical flaw, which again shows the built-in bias against catastrophism in the academic community. They argue incorrectly that because these black mats all look to be the same, and because these other black mats cannot also be caused by cosmic impacts, the Younger Dryas black mat cannot have been caused by a cosmic impact. Now that's just poor logic. We already know the Younger Dryas black mat almost certainly was caused by a cosmic impact. The framboidal iridium-rich magnetic grains and the nanodiamonds together in the same layer have no reasonable alternative explanation. So clearly that the logical explanation is that some and perhaps all of these other black mats are also caused by cosmic impacts. Now this is something these authors actually considered, but they rejected it immediately. And their reason for rejecting this idea, this most logical of conclusions, is that nobody else is looking at this question. In other words, it's simply peer pressure. They don't want to be the first to put their heads above the parapet. Well, that's just bad science. Not only is the multiple cosmic impact scenario the most logical conclusion for these observations, but it's exactly what is predicted by Kluber-Napier's theory of coherent catastrophism, which says that a giant comet has been breaking up in the inner solar system, causing mayhem on Earth over the last 30,000 years or so. Now, another thing I find really interesting is the timing of some of these other black mats. Now, in my book, Prehistory Decoded, I suggest the 8.2 kiloyear event, which was a major climate fluctuation around 8,200 years ago, was also triggered by a cosmic impact, just like the Younger Dryas event, and that this would help to explain the anomalous weathering seen on the Sphinx of Giza. And right here, we have the first geochemical evidence that I'm aware of that supports this. This is potentially then the 8.2 kiloyear black mat. And it seemed to be right here in South America. This is where this black mat is located. But look at some of the other dates as well. We see that there seems to be some correlation of some of these black mats with the end of the Younger Dryas period. So maybe that was also triggered by a cosmic impact. Essentially, this work opens up a Pandora's box of potential cosmic impacts over the last 30,000 years or more. But of course, much more investigation is needed for these other black mats to see if they really do have a cosmic impact origin. We can't be sure of that right now. Now, a week after this paper was published, we have this amazing paper by Van Hoesel et al. Now, these researchers are all from some of the top universities in the Netherlands. And this paper is published in PNAS, Proceedings of the National Academies of Sciences, which is one of the world's most prestigious journals. So this has all the hallmarks of a good paper. But it just kills me how bad this paper is. I think it's the perfect example of how it's possible for researchers to draw completely the opposite conclusions from the ones they should based on their own data. So let's see what they did right, and then we can see what they did very wrong. Now, like Tian et al. From the previous year, 2011, they looked at a black mat known as the Oslo Horizon here on the European continent, which is located in the Netherlands. And it's thought by some to be an extension of the Younger Dryas black mat into Europe. Now, once again, they analyze various geochemical signatures from within the black mat, which is this little band here of slightly darker sediment. And they find an abundance of nanodiamonds within this black mat. So we've now had the nanodiamond anomaly confirmed by 4 independent research groups. So it looks like Dalton et al. Must have done something wrong. But they don't stop there. They also take lots of radiocarbon measurements from the charcoal pieces in this black mat layer. Now, presumably, they're expecting these measurements to show this black mat has completely different age to other sites where the black mat is found. Now, you have to read the paper very carefully to find out what they're actually doing here. And it took me several hours to figure it all out. And by the way, many academics, when they're refereeing papers for publication, don't have that kind of time to spare. So unless you're paying attention to the details, this kind of sloppy work can easily slip through. So what they do is take 14 radiocarbon measurements from different charcoal samples from a short vertical 10 centimeter high sequence through this layer. So the sediment they analyze begins in this darker layer and then continues up above this dashed line by another 5 centimeters into the slightly lighter sediment. Now we can see from this table, from the depth, that the 12 of their samples are from within this dark layer, but 2 are about 4 to 5 centimeters above it. Now they assume this black band here was deposited in one go, and so for that reason they take the average of these 12 dates from within the black mat, which is perfectly reasonable. Indeed, just by eyeballing their data, which is plotted here, just by eyeballing this data, we can see that it's perfectly consistent with the variation of a random variable. So taking a straight average is absolutely fine. Now they find that this average gives them a date of 10,870 plus or minus, well, that's at 1 standard deviation, so it's plus or minus 30 years at 2 standard deviations. Now that date, which they haven't plotted here, that date, 10,870, is completely consistent with the date of Murray Springs black mat, and it's also consistent with estimates of the Younger Dryas event, the date of the Younger Dryas event. And just to be clear, so there's no confusion, we're dealing here with uncalibrated radiocarbon ages, so raw radiocarbon ages. We don't need to worry about calibration curves. Anyway, this is their initial finding, this date, which is perfectly consistent with the black mat at Murray Springs and with estimates for the Younger Dryas boundary age. That's their initial finding. Of course, that's not what they're expecting. So they reject this initial result, and instead they add in these two additional data points taken from above the black mat. Now, according to them, they think these new pieces of charcoal above the black mat were somehow moved by tiny creatures, and the fancy word is bioturbation, from the black mat into this into the layer above. They have absolutely no evidence for this, but it's what they think has happened. So then they go through another statistical analysis, which includes these two new data points from above the black mat. But in the end, they reject that analysis as well. So what they finally do, if you can read through all their text, what they finally do, the method they settle on for dating their black mat is this. They reject the idea that these data points are randomly distributed, are from a randomly distributed variable, and instead decide that all of this variation, all of this random variation in the data is due to an old wood effect. Now that's a really strong assumption, and I cannot see any justification for it. By assuming all of the variation in this data is caused by the age of the wood before it was burned and turned into charcoal, that allows them to suggest that the date of the burning event corresponds to the youngest data point here, which doesn't even belong to the black mat. So you can see where this is going. We only have to look at their title to find out what their conclusion is. Nanodiamonds post-date the Alarod Younger Dryas boundary. Well, that's completely absurd. So let's be absolutely clear what they've done here. They've dated their black mat by radiocarbon dating a piece of charcoal from 5 centimeters above it. It's just ridiculous. In fact, they actually showed with their initial calculation that their data is completely consistent with the estimated age of the Younger Dryas event. All right, we have a couple more papers to review, so let's get on with them. I'll do it very quickly. Both are strongly supporting the Younger Dryas impact theory. First, we have this paper by Bunch et al. That examines what they call very high temperature impact melt products found at the Younger Dryas boundary. Now, the most important thing for folk interested in Göbekli Tepe is that they find that these things in what they think is the Younger Dryas black mat at Abu Huraira. Now, Abu Huraira is only about 100 miles south of Göbekli Tepe. So straight away, they are potentially extending the Younger Dryas black mat into another continent, West Asia. And these are the kind of things that they are talking about in this paper. They've got these odd-shaped, glass-like agglomerates and the spherules, which they find in this black mat layer. Now, we previously dismissed the spherules as evidence because they're too difficult to define and count. And in the Requiem paper from last year, the Requiem authors dismissed these glassy agglomerates or melt products as probably having a natural explanation, such as a normal wildfire. But BuncherTell in this paper perform a lot of detailed geochemical evidence and conclude that these objects found in this black mat layer are, let's find their words, they find that these, they call them Younger Dryas boundary objects, are similar to material produced in nuclear airbursts, impact crater plumes, and cosmic airbursts, and strongly support the hypothesis of multiple cosmic airbursts or impacts around nearly 13,000 years ago. So that's their conclusion. So this adds further weight to the impact theory. Now, the problem I see with this is that although it's nice work, it's hard to use these materials to define the Younger Dryas boundary. They looked at 16 different sites in this work, but only 3 had these types of material. Presumably they were closer to specific airburst or impact sites. And moreover, all of these experiments are very laborious and complex. It would be much better if they could find a more obvious impact indicator, a much easier indicator to measure, so that other research groups could easily confirm or refute their evidence. The next paper is from LeCompte et al. Now, this paper from LeCompte et al. Tries to understand why Saravel et al. In 2009 were unable to reproduce the Comet Research Group's findings for impact spherules and magnetic grains and so on at various Younger Dryas black mat sites. Now, again, we've previously dismissed the spherular evidence as being too difficult to define. Nevertheless, these authors press on, and if you go through the text, you'll find they find some fairly convincing reasons why Saravel wasn't able to reproduce the spheral results. And apparently it all comes down to the precise details of the experimental procedures used. Okay, now that's fine if we accept the spheral evidence as being useful, but I'm not convinced we can. Now, more important from our perspective is that their work actually supports Saravel's et al.'s claims that there are no peaks in the magnetic grains at the Younger Dryas boundary. So let's just find Saravel's work again. So here is the paper by Saravel et al. And this is their their main results. And these plots in grey here are the magnetic grains in grams per kilogram at various sites through the Younger Dryas black mat. And they don't find the peaks that the Comet Research Group found in magnetic grains. So the important thing is that the paper by LeCompte et al. Actually supports that. So there are indeed not peaks in magnetic grains at the Younger Dryas boundary, and perhaps this one at Lubbock Lake is just the randomness in the data. So it seems then that by themselves, the magnetic grains are not a good indicator of a cosmic impact. Actually, this makes a lot of sense. Iron is the most common element within Earth, and one of the most common in Earth's crust. There are many minerals and rocks with high fractions of iron, so we can expect iron-rich grains like these to be everywhere in some sediments. So we need to be very careful with the magnetic grain evidence. We should only be interested in those grains that have high concentrations of exotic metals like iridium and have the framboidal surface texture that indicates rapid quenching. So the data from Murray Springs is still fine because those magnetic grains have these signatures. So where are we at the end of 2000 and 2012. We've seen that iridium-rich magnetic grains with rhomboidal surface textures are abundant at Murray Springs, and this has been confirmed by a couple of independent research groups, and is an excellent signal of a cosmic impact all by itself. Then we have 4 accounts, not including the work from Mexico, which we had to reject, of nanodiamonds at the base of the Younger Dryas black mat, which seems to extend across North America, Greenland, and into Europe, and perhaps into the Near East as well, near Göbekli Tepe. Again, these are an excellent signal of a cosmic impact. Even if opponents of the impact theory have some doubts about how they can be formed, they suggest that perhaps they are formed by natural wildfires, for example, but there's no evidence for this. So given they occur in the same place as the iridium-rich rhomboidal magnetic grains, and given that nanodiamonds are known to be produced by high-energy explosions, it's pretty clear that these nanodiamonds have been produced or dispersed by a cosmic impact. Now, other impact indicators like the spherules and the melt products, although they're interesting for the overall story, are much harder to define, measure, and analyze consistently, and so in my view are therefore less useful in locating the Younger Dryas boundary. We really need to focus on things that are relatively easy to measure so they can be easily corroborated or refuted by other research groups. So 2012 was a good year for the impact theory. It's clear that the Younger Dryas black mat contains the signals of a cosmic impact. And once again, we see how poor the efforts of their opponents are in refuting their data. But it's still not clear just how massive and destructive an event this was. Did it really cause the Younger Dryas climate change, megafaunal extinctions, and human cultural changes at this time? Okay, if you like that, then stay tuned for the next video, which will follow in a couple of weeks, and take a look at my blog, martinsweatman.blogspot.com, and my book, Prehistory Decoded. So in the next video, we'll look at 2013, and that's a pivotal year for the impact theory, as a new impact marker is discovered that is easy to find and measure.